All right. Hi, everyone. I'm Dave Intner. I'm an architect with Southern California Edison in our Codes and Standards group. Um, Happy that we can partner with the AIA LA chapter to provide some tools, training, and resources to support architects with their energy code knowledge and compliance. We're very happy to have Brian Selby with us today. Brian is an energy consultant and the president of KBEC, the California Building Energy Consultants Trade Group, uh, and is one of our master trainers that is a subject matter expert and helps to inform code development throughout the process. One of the top experts in terms of the changes to the code, where it's headed, and we've put together these code breaker presentations to give kind of a bite-sized lunch and learn length presentation on these various code topics. Of course, we have a whole wealth of additional code information on the Energy Code Ace website, which is the program that I help to co-manage along with my other utility partners statewide. But today we're going to be focusing on the forthcoming changes for single family construction that will be going into effect January 1st. So just over 3 months to build within the 2022 code, or at least get permitted within the 2022 code. You can, of course, keep building as long as you get your project into the building department before December 31st. But yeah, clock's ticking. Many of the projects that you're working on now are likely going to be getting permitted after that date. So this is stuff you're going to want to make sure you're on top of. And I'm glad that we have Brian here to help illuminate that. So without further ado, Brian.
Great. Thank you, David. Appreciate the introduction here. Welcome, everybody. This is our 2025 Codebreaker, essentially overview of the single family changes as compared to the current code cycle that we have, the 2022 code cycle. So this is a 1 hour presentation. We cram a lot of information in a very short amount of time. So I encourage you to ask questions. You're welcome to type your questions in the chat window. And if anyone needs to speak out loud, just raise your hand. Let me know. That way I can address those questions. So, all right, without further ado, let's dive into our training here. Couple of things, our objectives here. We want to get you up to speed with the new requirements or those requirements that have changed from the current code cycle. So we're talking about the 2025 Energy Code and when it goes into effect. We'll be talking about those requirements that have changed to the single family building occupancy type, both mandatory and prescriptive requirements covering the breadth of the code there. You know, envelope requirements, mechanical system requirements, and of course, our renewable energy requirements for solar PV and battery and such. So, got a lot to cover. I'm not going to spend a lot of time on our objectives here. I'm sure you folks can get up to speed on those rather quickly. A quick shameless plug from our funder and sponsor here, energycodeace.com. If you haven't been to the website recently, we've made some improvements to our tools, training, and resources. Just point out a couple of tools I think would be very helpful for you in getting up to speed with some of the requirements. We have the 2025 version of the reference ACE available. It's an online version of the code itself, Title 24 Part 6, as well as the administrative code, Title 24 Part 1, and good, easy way to access that. So training, take a moment, check out our other training topics. We have very comprehensive training for designers, architects, engineers, energy consultants, plans, examiners, building inspectors. So lots of training available through Energy Code ACE, as well as our resources. These are very helpful, in-depth resources that you can use as reference or fact sheets about various areas of compliance. So not going to bore you with too much information on Energy Code ACE website, but you can go there, check out the information, and let us know if you have any questions. A couple of things before we get started. Our course conventions, you'll see we use these as just a reminder of what type of code requirement that we might be talking about. That gavel symbol, those are mandatory requirements. Always have to be met if your project triggers a mandatory requirement if it applies. Prescriptive, that mortar and pestle, that just means that that is one of the ways to demonstrate compliance prescriptively. Meet all of the prescriptive requirements for your project in its respective climate zone, and it automatically complies. When you can't do that, or maybe you don't want to because it might restrict the design, we have the performance approach, the scale approach, where we're using the proposed design compared to the standard design, essentially that building with all those prescriptive requirements. And if the energy usage is equal to or less than what you're allowed to use, the project complies. So keep those in mind as we're going through this, and let me know if you have any specific questions regarding the type of measure or anything else that we covered today. So, all right, we're going to take a brief overview of the code requirements, kind of the overarching requirements that apply to various occupancy types. This is the full list of occupancies that are covered or regulated under our energy code. A couple things I'd like to point out. I know this is a residential single family class, but we have a brand new occupancy type that is regulated under energy code, the laboratory buildings. So that is brand new. We've broken down our residential occupancy types to what is most likely fitting within that occupancy group. So we've highlighted the R2 and R4 occupancy group. Those are primarily going to be all multifamily buildings, whereas R3 is most likely going to be a single family in some cases, if it's a congregate uh, group home or facility, it might be classified as a single family under an R3. So, um, yeah, good question. Are we going to get access to the PowerPoint? I have a workbook for this course, and I will make sure that Dave disseminates that information to everybody here today. So. Great. If you weren't aware, the 2025 Energy Code goes into effect January 1st, 2026. So that 1 year delay between when the codes are adopted and when they go into effect. And that's the policy. Now, keep in mind, this is for residential construction. This is kind of a unique code cycle. We're going to be living with the 2025 code for 6 years because of recent legislation that has passed. So not true for non-residential or hotel motel, but for our single family, multifamily, we're going to be living in this code cycle for some time. So get acquainted with it. You can download PDF versions from the Energy Commission's website, or better yet, go to the energycodeace.com website and use the reference ACE. A little bit easier way to interact with those codes. All right, a couple things about our single family construction, our efficiency ratings or compliance metrics that have been used. Our energy code is continually evolving in this respect. Under the current code right now, we use for new construction, we use a metric called EDR, or Energy Design Rating. It's an index score, uses a reference home that is built to 2006 IECC standards, International Energy Conservation Code standards, that essentially establishes this range of efficiency, kind of like a miles per gallon sticker on your car. That way we can compare different buildings in different climate zones and still be talking about the same measure. Now, this is currently required to evaluate building energy efficiency in terms of the source EDR metric. That's a hourly source energy, essentially establishes the proxy for carbon emissions. The EDRE, that's the efficiency of the building. That is essentially the regulated energy use, so the overall efficiency rating for that building. And then the EDRT is the effect that the solar PV and flexibility measures have on the overall efficiency. So for a new construction project to comply under the 2022 code using the performance approach, all three of those metrics have to comply in order for that project to demonstrate compliance. Additions, alterations, still using the term of TDV, or time dependent valuation energy. Probably going a little bit too far in the weeds here, but let me get to what the 2025 code is proposing. So Rather than continuing to use the metric of energy design rating, the Energy Commission has changed gears and has used the converted the TDV metric into what's called long-term system costs. So this is a way to look at the projected present value of the cost to California energy systems over a period of 30 years. So this, I believe, is a more effective way at looking at our energy usage in our buildings here in California. So for a new construction project to comply using the performance approach for the 2025 code, we still have source energy, still looking at the carbon emissions. We have LSC efficiency, again, looking at the overall efficiency of the building components and systems, and LSCT, that's the total efficiency after factoring in solar PV and other flexibility measures like batteries. So what does that mean in terms of compliance? Well, there are multiple factors. Before we get into the application of this, there was one more metric that applies to certain climate zones for new construction projects. If you're building a new single-family home or new construction ADU in climate zones 4 and 8 through 15, there's an additional metric that must be met. It's called peak cooling. So peak cooling is defined as that mechanical cooling during those high peak demand hours between 4 p.m. and 9 p.m. Typically, those are in the summer months, right? So this metric is designed to as a stopgap to prevent trading off of good cooling measures for meeting heating requirements. So this establishes a annual budget for cooling energy usage. You can see there that the proposed design is set by the standards, and as long as your project is using as much energy or less of those peak cooling values, the project also complies. So let's take a bigger snapshot at all four measures here, if those apply to your project. So that efficiency LSC, that's looking at the overall building's efficiency, and it includes features like the building envelope, walls, ceilings, floors, windows, and doors. It includes all of the fan systems, let's say for ventilation fan and for HVAC distribution, the HVAC system efficiency itself, the domestic hot water system, and other loads that are regulated by our energy code, including lighting loads and assumptions for plug loads. Moving over to our total LSC, this score represents the total amount of long-term system costs after factoring in those uh, photovoltaic or solar PV on-site power generation and those flexibility measures like batteries or a strategy to pre-cool the home before those high demand tariffs go into effect, that 4 to 9 p.m. area. Um, our source EDR, as I mentioned earlier, this score represents the building's efficiency in terms of hourly source carbon emissions. So essentially looking at not only the on-site carbon emissions, if it's a mixed fuel building, say either propane or natural gas, or those carbon emissions associated with the generation of electricity from the source. So those are all included. Moving over to our peak energy again, this represents the total amount of mechanical cooling site energy that occurs during those peak hours from 4 to 9 p.m. in those hotter climate zones 4 and 8 through 15. So now for a building to comply, here's a good representation. This is an excerpt from the CBEC-RES compliance software. It's one of the software programs that is produced by the California Energy Commission. You can see over there, we've highlighted the compliance metrics in their respective colors there. And essentially, the proposed design, those are the features that the building or dwelling is proposing to use to meet compliance. Uh, and those are compared to the standard design. This is what the energy code allows. So you can see for all four compliance metrics, all four must comply, meaning that the proposed energy, LSC energy use has to be equal to or less than what the standard design is. And if it is, the project complies. Now, if one of these metrics fails, the entire project does not comply with the energy code. So all four must comply for a project, a new construction project to be compliant under the 2025 code. For additions and alterations, it's just the amount of long-term system cost or LSC values, as long as the proposed design is equal to or less than what is allowed, the project also complies. Great. A couple things I want to talk about. There's been some terminology change in the energy code. Up until January, HERS raters, which refers to a classification of a third-party inspectors. Those are the folks that usually go out and do the duct leakage testing, airflow testing, fan efficacy testing. Their title is changing from HERS to ECC, stands for Energy Code Compliance. We as instructors here like to refer to it as the EC, however you want to pronounce that, the EC rater. So moving forward in January, we're going to be referring to those folks, those third-party raters as ECC providers. Those are the organizations that are approved by the Energy Commission to administer a ECC program. The ECC rater, that's the individual who's certified to go out and perform these field verifications and diagnostic tests. And then there's an ECC rater company. That's the company who the rater works for. So moving forward, I might even mistakenly call them HERS raters, but just understand what we really mean is the ECC rater moving forward. All right. Our first check your understanding question. You're welcome to type your answers in the chat window if you want to participate here and let me know what you think about these. Which energy efficiency rating is used to evaluate single family building performance under the 2025 code? Is it the energy design rating? Is it the long-term system costs? Is it time-dependent valuation or life cycle costs? Let me know in the chat window what you think. Awesome. I'm seeing A, EDR. I'm seeing LSC, which would be B. Any others? Any other responses? I see another LSC. Good. Well, if you're following along, you'll see that LSC or long-term system cost will be the compliance metric used for evaluating uh, all types of new construction, single-family construction moving forward. In fact, all building types using the performance approach from January on will be using this metric of LSC. So good. Awesome. EDR currently being used for the 2022 code. That one will sunset in January, so we won't be seeing that metric used. All right, question number two. A new single-family home requires field verification and diagnostic testing for quality insulation installation, otherwise known as QII, under the 2025 Energy Code. Who must perform this work? Is it the HERS rater, the installing contractor, or the rater? ECC rater. Awesome. I'm seeing C's on the response here. Absolutely. Yeah. We can still call them HERS raters. Just know that they're referred to as ECC raters under the code. Awesome. Good. Well, hopefully this information is helpful. Let me know if you have any questions. Happy to respond to those either in the chat or out loud if you want to raise your hand. All right, let's move into some mandatory requirements here. Again, as I mentioned, mandatory requirements, if they apply to your project, they must be met. You can't trade these away. You can't performance your way out of mandatory requirements. These are backstop measures to ensure that at least these features have been met. Now, keep in mind, mandatory measures don't determine whether a project is compliant. That is either the prescriptive approach or the performance approach. But a project cannot comply if it doesn't meet a mandatory requirement. So moving to our wall insulation, minor change. We've seen the minimum insulation requirement for 2x4 walls move from an R13 insulation to an R15 insulation. If you're talking in terms of U factor, that's changing the overall assembly U factor requirement from 0.110 to 0.095. So R value, the higher the resistance to thermal transmittance, the better. U factor is the rate at which heat transfers. So the lower the rate of heat transfer, the better thermal characteristics for that product. So moving to our 2x6 walls, assuming that these are wood framed walls. Again, either demonstrate the cavity insulation as a nominal R21, or the overall assembly is a 0.069 or less. Either one, these numbers are exchangeable, either meet the nominal R value or the effective assembly U factor for that. Good. Moving over to fenestration. We've seen the energy code ratchet down the maximum U factor requirements. Under the 2019 code, they were at 0.58. 2022 code, the current code in effect, they've gone down to 0.45. So in the 2025 code, we're going to see those maximum U factor for fenestration that includes vertical glazing as well as skylights cannot exceed a maximum weighted average U factor of 0.40. So this could be tough for remodels. In some cases, clients want to reuse existing windows. If that window is not NFRC rated, it's never going to meet that point point 0.4 U factor. So make sure that information is available on the plans and those projects are meeting the requirement. Now, there are exceptions. You can have up to 10 square feet of fenestration or 0.5% of the conditioned floor area of the building could be greater than zero point 0.4. So that's just that amount of glass is exempt. Also, there is an exception for a specific type of fenestration. You get up to 30 square feet that is exempt to the U factor requirements for a dual glazed greenhouse or garden window, essentially a manufactured product that bumps out that has uh, uh, more than one side to it. I think you folks know what I'm talking about. So those particular products get an exception. So there's also an exception in the code regarding the amount of glazing in a particular glazed door opening. So if you have any questions about some of those, let me know. Happy to answer those. Also, I'm going to be giving you a way to contact me directly for questions if you have any after this class. So now one of the other points about this maximum U factor requirement, the Energy Code is now considering projects that are built in high hazard fire zones. Wildland Urban Interface, Chapter 7A of our building code, allows for or requires fire resistive construction. So if you're familiar with how some windows achieve that, specifically our non-metal windows like the vinyl windows, they put certain amount of steel in there to help that window stay in place when it is exposed to fire. So if the project is located in a wildland urban interface or WUI area, it is exempt from the zero point 0.4 U factor maximum requirement. All right. A couple of things I like to point out. The reason why I said the reuse of existing glazing is going to be difficult to get compliance or meet this mandatory requirement is because if that particular fenestration product is not NFRC rated, meaning that the National Fenestration Rating Council hasn't provided a rating for that product, then it would have to use a default value. And you can see there's no product on table 110.6a that lists the default fenestration U factors that would meet that zero point 0.4 U requirement. So that's why I say it might be rather difficult. So Ruben says, I once read that if R19 batt insulation is installed in a 2x4 stud wall, once can count the wall with an R18 value. Is that true? No, that's not true. So it's highly frowned upon to compress insulation into anything less than what the manufacturer requires. So, and if you did that, this particular installation wouldn't meet the quality insulation installation requirements for compression. So, R19 bat in a 2 by 6 wall will produce an R18 overall effective value. So, now there is a higher density bat. Those are essentially smaller pieces of fiberglass or insulation material, so that the heat transfer takes longer to radiate or conduct through uh, that product. So yeah, so yeah, that might be true under different conditions, but for code compliance, that wouldn't be allowed. So. All right, moving on to some other mandatory requirements. Load calculations. Now, load calculations have always been a mandatory requirement. We have to determine what the heating load is based off of the geographic area the project is located in. We're talking about heating loads during the winter months, cooling loads during the summer months. These must follow one of these three methodologies, either the ASHRAE Handbook Fundamentals, SMACNA, or ACA Manual J. So the code does have a new requirement for additions, saying that rather than doing a room by room load calculation, if you're doing an addition, you can assume a block load, meaning that you can just take the entire zone of the addition and the existing building to determine what those heating and cooling loads are. Whereas for new construction, the code is implying that a room by room load calculation be done. Now, in addition to those load calculation requirements, there are other requirements that are specifically designed for heat pumps. So we're going to be talking about some of the prescriptive changes for the baselines requiring heat pump technology. But if you understand how a heat pump works, extracting heat out of the ambient air and transferring that heat to the space or vice versa in cooling mode. Um, it's important that these systems are sized appropriately, meaning that in our colder climates, if the HVAC system is not designed to meet the heating load at a very cold outdoor ambient temperature, then that product is undersized and we're going to be wasting energy. So the heat pumps must not only be sized correctly, but also verified by that ECC rater that 17-degree and 47-degree outdoor temperature rating meets the load. So you can see that there is a good requirement for that. Um, Good. Thank you, Dave, for talking a little bit more about the insulation issues. Yeah, so thanks. Let me know if anything else comes up. Now, in addition to the load calculation requirement language that was added to the 2025 code, there's a new space conditioning equipment selection requirement that specifically applies to uh, the heating capacity. So you'll see there um, that for furnaces, selection of that system needs to be based on the ACA Manual S. That's their system sizing calculation. In order to get to a Manual S, you have to do a Manual J. That's our load calculations. You have to do a Manual D, which is a duct design, assuming that this is a ducted system. And then you get to system selection, which is the Manual S. So for heat pumps, the you need to meet the minimum requirements of the building code uh, without including supplementary heating. So let me explain that here for a moment. Heat pumps extract heat out of the air. They can't deliver heat continuously. There's a thaw cycle. So during that thaw cycle, if it is needed to provide supplemental heating. Typically, that's electric resistant supplemental heating. That that the heating load be met without the supplemental heating, meaning that the heating load has to be met solely on the capacity of the heat pump without triggering that extra supplemental heating. There is no limit uh, to minimum capacity for cooling. There is no limit to maximum capacity for heating for new construction. So once we get into additions, alterations, that will change slightly. All right. This is regarding the supplemental heating and the use of heat strips that I just spoke about. Once the heating load is met, any heat pumps using supplemental electric resistance heating shall not exceed the nominal cooling capacity. So the heating capacity cannot exceed the cooling capacity. Um, and that's multiplied by 2.7 kilowatts per nominal ton of that equipment. So there is some limitations on the amount of electric heat strips that can be uh, built into a heat pump. All right. In addition, some new language here in the mandatory measures section for thermostats, specifically for heat pumps. We've had mandatory requirements in the code for decades requiring setback thermostats. And those apply to all space conditioning, central space conditioning equipment. When the space conditioning equipment is a heat pump, there are additional requirements that it display the outdoor air temperature, receive um, outdoor temperatures either through an air sensor or through a weather service, internet-based weather service. Locks out supplementary heating when the temperature is over 35 degrees ambient outdoor temperature, and of course enables it at 35 degrees or below. So that last one there basically says that there's an indicator light when that supplementary heating is on and it can't stay on continuously. So that would be a huge waste of energy. So other requirements for the installation and testing of these, of course, there are some exceptions for system types and when those systems are serving build smaller buildings like less than 5,000 square feet. All right, moving on to our battery ready requirements. Again, we've seen these were introduced in the 2022 code. So the updates to that are providing a little more clarification on when this is required and how folks can achieve compliance with the battery ready requirements, as well as a new exception for removing that requirement. So battery ready applies to all new construction projects. So battery ready is not something that is required for an addition or alteration. This requires that the provisions for the future installation of that battery are installed. This means that some of the circuits are installed. There needs to be 4 circuits that run through a sub panel. Um, there are requirements that reserve space next to the service panel be made, as well as any interconnections and wiring be made. Now, the new exception outside of that code requirement says that if the battery or if the service panel for that dwelling is rated for 125 amps or less, then battery ready is not required. Keep in mind that the requirement for battery ready requires that the service panel have a 225 amp bus bar rating. So in the situation where the newly constructed space has a much smaller panel design, then it's not required to meet the battery ready requirements. All right, moving over to ventilation and indoor air quality. I apologize for the jumping around. We're really just covering the major changes here. So I know this might seem a little disjointed, but uh, I would invite you to participate in one of our more comprehensive courses if you want to get all the full information on these requirements. So, some of the updates for our ventilation and indoor air quality requirements. If the strategy of using a balanced system, equal amounts of supply air and exhaust air for ventilation, or using a supply only ventilation strategy. So, this requires that the incoming air be filtered, and there are new accessibility requirements on that filter access. So that needs to be serviceable so that the occupant can change that filter periodically to ensure that fresh air is coming in. So essentially, anytime that filter is in an inaccessible area, the serviceability goes down. So essentially, putting these devices or filters in accessible areas. So there are some exceptions for this. Put a fault indicator display inside, essentially meaning that there is something wrong with the filter system. If that filter is accessible from inside the attic, that is a very nice way to overcome accessibility issues. So additional exceptions apply when that filter is located in an attic behind an access door. So. All right, moving on to our pool and spa requirements. Again, pools and spas have always been regulated under Energy Code. It just there are new requirements here specifically covering heated pools and spas. So either a newly constructed swimming pool that is heated or a newly constructed spa as well. So there are 5 options to comply with this. Either install a solar pool heating system with the surface area of the collector at 60% or less of the pool surface area. Install a heat pump pool heater with the primary heating system sized according to the reference joint appendices chapter 16, specifically JA 16.3. If you have supplementary heating, very similar to our indoor space conditioning systems, um, heaters can use any energy source. It could be electric resistance, it could be a gas source as well. So 60% are greater, isn't it? Yes, sorry. Thank you, Ron. Appreciate that. I looked at the wrong direction on that one. Third option, heating system that delivers at least 60% of the annual heating from on-site or renewable or recovered energy. That option requires that a licensed mechanical engineer provide the analysis for that. Fourth option is a combination of a solar pool system and a heat pump without supplementary heating. So you can see there's a lot of different options here. Now, the last option is kind of an option for technology, future technology to come in and replace this. Currently, it would have to be determined by the executive director of the Energy Commission to use no more energy than any of those system types listed above. So open door for future technology there. All right, a couple of the other mandatory changes regarding lighting, high efficacy lighting. Uh, the requirements are essentially the same as the 2022 requirements, with some exceptions here. Uh, all luminaires and light sources must be high efficacy. That hasn't changed. All lighting requirements are mandatory, meaning that you can't trade them off using the performance approach. That has not changed. Uh, Anything that is rated for JA8 2016, JA8 2019, or 2022 can be used. Those are referring to the sticker or certification stickers on our luminaires and lamps. What has changed? The code was simplified, meaning that there was a lot of information located on tables to identify the luminaires are high efficacy or not. That has just been incorporated into code language. So we've removed the table 150.1a. Also, for 2025, high efficacy lighting is now supported with those JA8 certification stickers and markings. So a couple of things regarding our state appliance efficiency regulations. You'll see that as of January 1, 2024, no more screw-based compact fluorescents and no more of those push and turn compact fluorescent, those bayonet style bases. Those are no longer allowed for sale in California, whereas as of January 1, only pin-based compact fluorescent lamps or linear fluorescent lamps are allowable to be installed. So good. Um, You'll notice here in our building energy efficiency code, fluorescents have been removed as lighting options of the high efficacy. So that what used to be listed on table 150.0A from this previous screen uh, now has been incorporated into code, which no longer lists those fluorescent units as high efficacy. Great. All right, a couple of check your understanding questions here. We'll just do these quickly here. This product label shows use of R13 insulation in a 2x4 wood frame wall of a new single family home. Would it comply under the 2025 Energy Code? If this were the only insulation in that wall, would this comply? Yes, A, B, no, possibly under the performance approach. Okay, could they add anything else to this wall that might make it compliant? You might change some of those answers. I see some folks changing from B, absolutely not, to possibly, right? So in this situation, if all they installed was R13, they couldn't use the performance approach without adding more insulation and comply. So they would have to add rigid continuous insulation. That would be one option to get this R13 to comply, but wouldn't be allowable with only R13. So yeah, how we phrase this question could make a lot of difference in your response here. So. All right, what do you think on this one? What is the maximum electrical service allowed for a new construction single family dwelling unit to claim a battery ready exception? Right? Talking about this service panel or meter, right? If we want to meet an exception under the code, is that 125 amps or less, 200 amps or less, or 100 amps or less? I think everybody is on board with, yeah, A is the correct answer there. That was a new exception if that service meter is rated for less than 125 amps or less. Great. Let's dive into some of these prescriptive requirements here. Looks like we got about 15 minutes left. I think we'll make it through most of these here if I stay on task. All right, we've seen a new prescriptive option for cathedral ceilings. Now, under previous codes, the current code 2022 and earlier, we only had prescriptive roof ceiling options for attic roofs. There were no options for compliance with cathedrals. So we've seen a little bit more granularity with our prescriptive requirements. Essentially, insulation uh, requirements meeting the option C, a non-attic roof needs to meet at least R38 cavity insulation in all climate zones. Now, keep in mind there must be an air space between the insulation and the roof deck when that insulation is installed. Not only prescriptively to meet the roofing material requirements, but also to meet the building code requirements. Building code 806.5, if I'm not mistaken, requires any air permeable insulation to maintain at least a 1 inch distance from the roof deck or any other vent openings or anything within that. So uh, prescriptively in this situation, you would need an airspace between the roofing material and the roof deck and the insulation and the roof deck. Both must occur in order to be compliant with both the energy code and our building code. All right, other prescriptive changes. You'll see this is an excerpt from table 150.1A. That's our prescriptive table. You'll see that some of the fenestration performance requirements for U factor have been lowered from a zero point 0.3 U factor to a 0.27 U factor in certain climate zones 1 through 5, 11 through 14, and 16. Whereas the solar heat gain coefficient or SHGC requirements have been reduced for climate zone 15. Let's keep that in mind. That maximum U factor requirement of 0.40 might have a little bit to play with this. But also to keep in mind for dwelling units with a conditioned floor area of 500 square feet or less in climate zone 5 may comply with a maximum U factor of zero point 0.3. So in the situation for small dwellings in climate zone 5, you don't have to meet the 0.27. You can still meet a 0.30 requirement. All right, moving to some of our mechanical system prescriptive requirements. You'll see that refrigerant charge verification is prescriptively required in all 16 climate zones if a heat pump is used to meet those requirements. This is a good thing. This is a quality assurance to ensure that the technician installing that unit installed the proper amount of refrigerant, not too much, not too little. So very important for heat pumps that they are charged correctly. Now, you'll see that for other types of air conditioners, when a heat pump is not used, it's still prescriptively required in certain climate zones. Moving over to the fault indicator display requirement. Now, keep in mind, um, this requirement is only applicable if the strategy of using a balanced ventilation system with an HRV or ERV system, though that means heat recovery ventilation or energy recovery ventilation. So when this strategy is used for compliance, then that device is required to have a fault indicator display. Like we were talking about earlier with the indoor air quality um, filtration requirements, that display is to tell the occupant, hey, there's something wrong with your ventilation system. It needs maintenance. So that's what that is for. There's some really in-depth requirements for this fault indicator display to qualify under the reference joint appendices chapter 17. Not going to get into these in any depth here, but just understand that minimum requirements have been set by the Energy Commission for these devices to ensure that they're indicating the correct issues. Like, for instance, checking the filter to make sure that it's clean, making sure that air is flowing through it. So we want to make sure that those devices are functioning correctly and get maintained appropriately. Now, one of the major changes for the 2025 code is you'll notice here for space heating, um, uh, you'll notice on the top line there, space heating if gas, the annual fuel utilization efficiency is NA. That means that prescriptively, you cannot comply if you're planning to install a gas space heater. The only space heating system allowed would be a heat pump. You'll notice the bottom space heating if heat pump needs to meet the minimum heating seasonal performance factor 2 in order to comply. So no longer do we have a choice. Our space heating fuel prescriptive compliance has been chosen for us. That is a heat pump. Now, if you're using the performance approach to comply, that means that if you use a gas furnace, that not only are you going to get a efficiency LSC penalty, you're also going to get a source energy penalty for using that gas space heating device. So it doesn't mean you're not allowed to use a gas space heating system. It just means that it is getting increasingly more difficult to demonstrate compliance with that system type. Whereas the heat pump system type sets the baseline for compliance for all new construction projects. Additions and alterations can still use gas furnaces, but for new construction, the default is a heat pump. Moving over to our domestic hot water systems, again, some major changes. Still not allowed to use a gas tankless or tank style water heater to comply prescriptively, but the options are um, a single 240-volt heat pump water heater. That is assuming it's not NEA Northwestern Energy Efficiency Alliance rated tier 3 or higher. Or you can use a solar water heating system with a minimum solar savings fraction of 70%. Essentially means that 70% of the annual hot water is produced by that solar thermal system. And that system can have an electric resistance backup tank. So I've already pointed out gas tankless water heaters are not allowed prescriptively in new construction. Again, if you're using the performance approach, you can use a gas source water heater. It just may take a lot of trade-offs, meaning that you'll have to exceed the code considerably in order to demonstrate compliance. Now, one of the changes to the exceptions here, we saw this change come in the 2022 code. It says new dwellings, 500 square feet or less, uh, may use an electric instantaneous water heater using the point of use distribution option. The language of instantaneous or tankless has been removed. Though what that means is you could use a electric tank style water heater to comply with the domestic hot water requirements of the energy code. If that dwelling is 500 square feet or less, using that point of use distribution option essentially limits the length or distance any hot water outlet can be away from the water heater dependent upon the diameter of the pipe that is being used. Also, dwellings with one bedroom or less may use a 120 volt heat pump water heater rather than that 240 volt heat pump water heater. Moving on to our solar PV requirements, no change in the equation. So equation 150.1C based on the conditioned floor area of the dwelling and the climate zone the project is located in, that equation hasn't changed. Um, the difference being is moving forward in the 2025 code, the performance approach will now use this equation or use the alternate options to set the baseline or the standard design for our solar PV systems. So the equation's the same, just the methodology for determining the minimum PV system size using the performance approach has changed to match the prescriptive requirement. In addition to the equation 150.1C, there are additional options of using the solar access roof area, otherwise known as SARA, to determine what the minimum PV system size is for a steep slope roof or a low slope roof. You would multiply the SARA, meeting the definition of SARA, what is included in SARA, excluding those things that are not the SARA, and multiplying that area in square feet times either 18 watts per square foot for a steep slope roof or 14 watts per square foot for a low slope roof. So that is brand new option for 2025. Now, the exceptions for installing solar PV have not changed. We still have an exception if the minimum PV system size based on equation 150.1-C indicates the requirement is less than 1.8 kW, then no solar PV is required to be installed. Again, this is taking consideration of the conditioned floor area of the building and the climate zone the project is located in. So those values may or square footages of buildings may vary based on your climate zone. There are additional exceptions to the solar PV requirements. Again, there are no changes to these requirements for the 2025 code. These exceptions are going to stay the same. Now, for additions, alterations, um, there are no PV requirements. Again, that only applies to new construction, but some of the other prescriptive requirements, as I mentioned along the way, when an additional water heater is installed to serve an addition, it must be a heat pump water heater, right? Prescriptively. If it's not a heat pump water heater, if you install a gas water heater, it would have to meet the heat pump ready requirements for that. And again, there are some exceptions to the water heater uh, type requirement, meaning that if the addition is 500 square feet or less, with that point of use distribution option, it's not required to be a heat pump water heater. Likewise, going over to alterations, glazing alterations that add fenestration area in climate zone 15. This is kind of trivial. Again, climate zone 15 reduced the solar heating coefficient requirements to 0.20. Means if you're doing that as part of an alteration, you can still use the 0.23 value prescriptively and comply. Space conditioning system capacity, again, prescriptively required for additions. There are new requirements for minimum capacity and maximum capacity. So we're not going to get into the details about that, but there are some exceptions. Obviously, if that system is a ductless system, or if that system is using a variable speed or multi-speed um, fan system in order to meet that. And if you have verified um, the airflow being at least 350 CFM per ton or better, then those exceptions don't apply, or those requirements don't apply. Again, we're running into some time constraints here. We're getting kind of in the weeds with some of these limitations here. I want to do a follow-up here, just while we have a few moments left in class. Open it up to questions and answers as I scroll through some of the resources and classes available at Energy Code ACE. Please let me know. You're welcome to speak out loud or type in the chat window. But we'll use this last minute here just to look through some of the fact sheets here available. So let me know if you have questions. Otherwise, I'll comment on some of these fact sheets. The what's new or what's changed fact sheets are very helpful. If you want to get up to speed, you need some documentation on those measures. You can download those through the Energy Code ACE website. And again, I'll be supplying the workbook for this presentation so you can reference back to some of these slides for future reference in here. Virtual classes, again, we teach very comprehensive courses for designers, architects, engineers under the 2025 code. Those are going to be coming out very soon. So, uh, and I promised everyone a way to reach me directly. I will share my email address on my closing screen, but a better way to reach me if you have specific questions about the energy code or a project, how to assess a project for compliance, uh, anywhere on the Energy Code ACE website where there is a opportunity to ask a question, whether that be through one of the links, question mark links, or the specific questions. You can submit a ticket, and if you made that topic a residential building topic, those go directly to me. I respond to those usually the same day, sometimes within the same hour. So if you want to get answers to some of your energy code questions, please reach out and submit those questions. So without further ado, I'm going to turn it back to our host here to close out, and I'll open up to questions.
Hi, everybody. Don't be shy while you have Brian still here, please.
I've got a question regarding wildfire hazard zones and
Sure.
windows that you mentioned earlier. Are there minimum solar heat gain requirements for those windows, or how does that work?
Yeah, a good question, Ron. So the solar heat gain requirements refer to the spectrally selective glazing, meaning it would only apply to the glass, whereas the WUI requirements refer to the U factor, and that speaks to the frame. So in that situation, there is a maximum U factor requirement 0.4 if your project is in a wildland urban interface. It doesn't have to meet that poor zero point 0.4 U factor requirement. It still needs to meet, if you're complying prescriptively, it would still need to meet the prescriptive solar heat gain coefficient requirements. Does that make sense, Ron?
Got it. That makes sense. Thanks.
Perfect. Yeah, it's just that maximum U factor issue for the windows in wildland urban interface areas. Good. Any other questions? Happy to address those. out loud if anybody wants to speak up or type them in the chat window. Great. Oh, you're welcome. These are fun classes. I'm glad to have this opportunity. Thank you for this. I'll turn it back to you.
All right. Thank you so much, Brian. And also thank you to Dave. You will both just do such a wonderful job of putting these together. And I know everyone really appreciates it, and it speaks for it with the engagement that you get in the chat and everything, and how well attended these events always are. So thank you everyone for joining us today. We will be reporting your CES within about 10 business days from today. So be on the lookout for that. And then of course I will be sending out an email that will have the link to Brian's PDF, and then the YouTube channel link once the recording is available. And then we'll also put all this stuff on the event page too. And I'll also be putting the links that Dave so graciously put in the chat for us, put those in the email as well. So look out for that realistically tomorrow morning. Thank you everyone for joining us. Thanks again to Brian Selby, Dave Entner. Appreciate you both very much. And I will stop the recording now.
Awesome. Thank you.